Hey, what's going on, folks? It's Mike here, and welcome back to the Deep Programming Language series. In today's lesson, we're going to talk about a concept known as a string mixin. Now, mixins in general are a way to just take code from a string or a file and literally insert it into your D programs. And this is code that should be valid and compile as normal. And what we're going to find out is this is actually a really nice feature that improves on things like the C preprocessor, but allows you to do a lot of the powerful generative coding type of stuff that you might have done with macros and other languages. So with that said, let's go ahead and dive into the Deep Programming Language website. And I'm just going to go ahead and just search mixin here on the search here. I'll show you how to get to the article that I want us to get in. So you can look at string mixins, which we're going to look at today, or you can go to the documentation, articles, and you'll find as well string mixins here, the same article. Now, again, we're going to find several different types of mixins throughout this series, and today we're talking about string mixins. There's something called template mixins that we're going to get to, but I think it's easier for us to just start with a string mixin. Okay, so what is this here? Well, basically this is the idea that I could just take some code here, a string, and mix it in. Now I've got a little example here that I think we're going to play around with here, and I'll revisit the article in a second, but let's just try with a really simple example of what a mixin is here. So let me go ahead and just create a empty D project here, and what I'm going to go ahead and do here is let's go ahead and import standard IO here, and let's do a mixin here, and I'm just going to go ahead and do write line hello world, and let's go ahead and escape these strings here and make sure that we balance our parentheses, and I'm going to put in a quotation mark at the appropriate spot here. Okay, now let's go ahead and run this little program here, and it prints out hello world. Okay, so what's going on here is I've mixed in this string here. Now let's go ahead and make this just a little bit easier for us by removing this block of code here. Let's go ahead and grab this here. And what we're going to go ahead and do here is just assign it to a string s. And let's just mix in this string and look at it another way here. And let's see if I've done my parentheses right and I run it. Oops, looks like I got a compilation error. And it's telling me something very interesting about this. We'll debug that in a moment here. Let's actually get rid of it here, and I'm just going to make this an enum, and then I can run it here. Okay, so we're going to, again, this lesson's all about, or this series of a few lessons that we're talking about here with the generative programming and compile time programming is about stuff that we can do at compile time. Okay, so what did I do to change this example here? Well, basically, if we look at what this program is doing, the mixin here is just taking some known value at compile time. And that's really important, whether it's in this form here, which I'll, let's keep this example here. Let's put it back to how we had it here. And let's go ahead and do this example. So the equivalent code here, where I'm just mixing in, so at compile time, this literal string, because I know a literal string, right, something between quotation marks at compile time, I'm just literally inserting that into my code. Now, again, you're going to ask yourself, why should I do this versus just writing, well, write line, hello world, right? And if I run this program, it's going to do the same thing, both times here. The advantage is, again, as we sort of here, and I'll go ahead and give a comment here, enums are known at compile time, since they are constants. Well, I could actually generate this. I could write a function that actually gives me back this enum here. So let's go ahead and do something of this nature here. I'm going to generate a string called create message. I'm going to take in some string here that's a message, return the message, and let's go ahead and do the same thing here, where I assign to some enum, some message here. Let's go ahead and say create the message here. Hello from this function. And then what we're going to go ahead and do here is mix in here, write line, parentheses. I concatenate this with my message. And let's go ahead and, again, we'll have to be a little bit careful with our parentheses here. Concatenate this with another parentheses or matching quotations here. We need to end this semicolon, end our mixin, and let's see if this works here. And indeed, I get hello from this function, okay, this message that I created, and then I'm able to mix in that code here, and get, well, whatever my message is, which again, in this case is just hello from this function here. Okay, so it's just a simple little function, and it's known at compile time, this value here. So again, I'm just trying to show you that we can generate or compose functions to perhaps make something here. So for instance, I could, make this more interesting and maybe call some functions to, uppercase the string or something. And again, that would be evaluated at compile time, which is really cool, and mix in this message at compile time, which is neat. So anyways, I could compose this type of stuff here as well with these mixins. Now let's just read a little bit more to get our intuition a little bit. Because when I initially saw this idea of being able to just mix in code, again, immediately I thought of, well, why don't I just write it like this? But again, what I'm trying to get you to have a feel for is this idea that we can start generating stuff by calling functions that can do things at compile time and, write more interesting code here. So anyways, let's read a little bit about mixins here. Just to learn about what's going on. So for example, and this is getting into more interesting stuff here, I can actually generate a structure here. So again, in the same way that I wrote this little function here, let's keep this to the side here. And let's go to the top here. Maybe I could generate a more powerful function that writes a string, this time writing a struct here. Okay, that's pretty cool here. In fact, let's go ahead and just copy this piece of code here. Let me paste it in here. There we go. And what we're able to do now, if I make this a little bit bigger here, is, well, actually, maybe I should make this a little simpler. Since we just want to focus on string functions here, let's just call this thing, it's just going to return us a string here. Let's just have it literally return struct, the name of the struct, the int, some name for the one field that it's going to have here, and then that's it here. Okay, so let's see if I mix in that code here. And let's go ahead and copy this example here. I'll do it so that we just locally create this struct here. So now we'll have a new type here called foo. It'll have a int called bar here. And let's actually initialize then foo, my foo struct here, and then my foo struct dot bar equals 25 or something like that. And I think if we actually write out my foo struct, I think it'll give us something here. But let's see what happens here. Let's see. Oh, I'm getting some errors. Oops, because it's not a template. Let me get rid of this exclamation mark here. It's just generating us a string here from this function call. And again, really interesting stuff here. Here's the structure that it's printing out here, the type here, right, when I just do the right line. And it's storing the value 25 here. So I hope you're starting to get a sense of this idea of, oh, if I'm just generating strings, I can generate a string of anything. And I can generate a string of any valid D code. And that's actually the really powerful thing here. So if I want to read from some file, a bunch of these names, for instance, and then have a mixin that generates a struct called, foo or foo2, foo3, whatever, we can actually do that. And we can do this at compile time. And we can do this using things like a for each loop, for instance, that does this hundreds of times. So we can just generate code that we need if you're, say, processing or want to build these structs from, say, a spreadsheet, right? A comma separated value file. So these are some of the really cool things that we can actually do here. So let's read on a little bit more with string mixins. So obviously this is the form of the code that was generated here when we called our function. Again, I changed this a little bit. We're going to talk about template mixins and mixing in templates later on. But right now I just want to focus on strings here. But again, let's try to motivate this with what the advantage is. Because you might again have been asking, well, I can do these things with a C preprocessor, or other languages just have macro systems. Well, D doesn't have a preprocessor. And the advantage of that, one of the advantages is, one, you don't end up with like wild code like this, which I have seen. It's more hacky. I haven't seen it in a real code base. I'm sure it exists. Folks have claimed they've seen this, right? Where you just define the left and the right curly brace to begin and end because you want, a domain-specific language, or you like the Pascal syntax better, right? So you can't do this kind of stuff with mixins because the code that you're mixing in is valid D code, right? This has to compile during the semantic phase here, which is what the rest of this article goes on to tell you here. So I'll move out of the way if you want to pause and check it out here. But the mixins that you have, right, they follow all the normal scoping rules. They follow all the regular rules of the D code. And in a way, that's what makes it really powerful, because you're not, fighting or inventing like new languages effectively within D here. So that's really the cool thing about mixins. And again, today we're just focusing on string mixins, which is literally just anything in our code. Let's take it here. That's a string, and then that we can just mix in. Okay, so maybe you're not sold on this idea yet, but let's go ahead and do a few other cool things here. One cool thing that you can do is I can actually write another file here, and I'll actually just split this window here. Let's just actually call this data.txt for whatever reason. And I could actually just do this sort of same experiment, hello from data.txt here. Okay. And what I actually want to do now is mix in everything from this file here. Again, maybe you've got a bunch of code here. Maybe it's been generated or streamed in from the internet or something, or from your version control system to do a build. Then you can do mixin import. This file is called data.txt. And let's actually do an ls here just so you can see the data.txt file here. I'm going to try to run this. Let's see if it works as is. No, it's going to complain first. It's going to tell you error, need the -j switch to import text file. Okay. Part of this I think is for just being explicit where you're grabbing this data.txt file from. So I need to do -j and add the current directory here with just a dot here. And that'll do the trick here. And now you'll see I've been able to mix in everything from this file here. Right? If I wanted a plain text file with another struct called my data struct or something, I could also mix that in here. Okay, and we would have that available. Okay, that's mixing in and putting this code here. Now this is kind of an interesting pattern here. I'll just put a little note here. This is effectively what embed, or it's a thing you can do like embed, right? If you want to just embed data into your different files and bring them in. Now what's kind of cool is when you combine this with other features of D, like the version keyword, right? Like if I use version, I think it's Windows, we can mix this in here. So let's go ahead and run this. Well, this isn't Windows code, so we're not going to mix in anything here. Let's change it to Linux, which is what I'm currently on. And look at that. Now we have our code here, right? So when you do these sort of like selective preprocessor things, you can mix in code as you want here, okay? So just an example. So we will get into some more like powerful generative things here, but hopefully this gets your brain going just a little bit about what's kind of neat about string mixins, this idea of just mixing in strings of code here. Now you might again say, well, why am I writing, D code in this text file? Well, most likely you're generating this code, right? When you want to do some like meta programming, or you want to, maybe you have a Python file that's reading in a spreadsheet and generating D code from it, and you want to be able to read it in this language. I mean, these are the types of things you can open yourself up to doing, which is really kind of cool. Now, what can be a little bit annoying is debugging this. Like, let's say if I forget a semicolon here, and then I mix this in here, it's going to tell me error, semicolon needed, the declaration of I, and it kind of caught it here, I think, pretty well here. It's telling me it's like at this mixin. Since it's generating code, it is like, sticking in lines of code there, which could get a little bit tricky here. There is a mixin flag here. Let me see if it mixin, and I think you have to do like mixed code or something like that, create an output here. And now it's going to tell me, okay, for the mixed code at line 164 here. So let's go ahead and just see what happened. Now I've got this mixed code file here. Let's split this window here and look at mixed code. And now I can see like all the stuff here. 164 that's been generated here. And now I can actually see my struct here. Okay, so now it sort of helps me isolate what I've got here. So that's effectively if you've used your compilers for like C++ to spit out the code with the -e flag to see what's in the CPP processor, or just use CPP. This is the same thing that you can do here, right? So you can actually see how all of your code is expanding here, right? You can see all this other stuff that you don't care about, but what you care about is the actual error message here. Okay, so now I can go into this file here and say, okay, oh, I forgot the semicolon. And now I can run it, and it runs just fine here. Okay, so just a little debugging tip here. Again, you can output the full mixed-in code here. Alrighty, so that's mixins, string mixins specifically that we've looked at here, just giving you a little bit of a preview. So I would challenge you to think about trying some other exercises with this. So for instance, you can use things too that might be kind of neat here, like for instance, let's go ahead and say like with import format. Let's see, here's just one little example here. Let's go to our library here. I'm going to look for a standard format for formatting data strings here. Let's look at this one here. So you can use this for like creating strings in different types and so on. And that might be kind of a fun one for you to play around with mixins, right? This is just generating a string with the %s getting substituted by pi, and this %s value being replaced with 3.14. But you could use this with a mixin. In fact, let's just go ahead and do one here. Just to show you what I mean with these mixins here. So let's go ahead and do this format. Let's go ahead and say pi equals, and let's say auto pi equals. Let's just write out that line so you can see what it is. Oh, actually, sorry, let's leave that as pi. That's going to do the substitution, and let's do this here. Something like this. Okay, so let's actually write out that format string. S. Oops, I think we've already called some things S2 as well. Format example. Format example. And let's go ahead and compile that. And we get this line. This is what's generated here from this format string. Okay, so hopefully that makes sense what it's doing. It's taking %s, replacing it with pi, %s here, replacing it with this value, right? This is just a template. We've been looking at templates. And the format string will allow us to basically do what you've done with printf in like the C programming language, right? And I can just actually write this out in this way, but if I don't want to just write that out, I can do a mixin, and then I can write line, for pi here, because we know we've generated that code. Oops. Let's see. Yeah, we're going to get the same issue here with this auto. So we need to make it in enum. So it's made at compile time. That's one way that we can deal with this. And then there we go. We get pi is 3.14 because we've established it here with our mixin. So again, you can think about how to use this format string with cleaning up your code if you're writing functions like we did here. With the gen struct or the create message, just have a little format string that replaces things. So again, might be a fun little thing for you to play around with. So anyways, folks, hopefully you enjoyed that lesson on string mixins. As always, we're going to be covering some more topics on generating code with templates and string mixins and other types of mixins like template mixins, so you can follow along and track your progress as always on courses.mshaw.io. And hopefully you enjoyed this lesson. Hopefully you're having fun in seeing some of the powerful stuff in the D programming language. We haven't even gotten into some of the features like object-oriented programming. That's going to come later when we talk about classes and so on, but we're still getting into the really fun and nitty-gritty superpowers of the D programming language. So hopefully you're having fun. Hopefully you're enjoying it. And then as always, folks, thanks for your time and attention. I'll look forward to your comments below.